Hi! Today I want to share a tip for SwiftUI. How to achieve an animation driven by the position of a view within a scroll view. This effect was not trivial to implement in SwiftUI until I understood some key concepts. You can achieve effects like the App Store does to animate the app logo in the detail pages of apps. Let's break down the effect a bit. Initially, the navigation bar is completely transparent and the app logo and the name are under the app banner. When we start slowly scrolling in the content, we can see the navigation bar is becoming less transparent as we scroll. By the time the banner image is scrolled away, the navigation bar is fully opaque and there is a change in the back button. Now, if we keep scrolling, just a bit before the section with the app name and logo goes away, there is a quick animation where the logo and the name disappears, but at the same time, the logo appears in the navigation bar. If I scroll back, the changes are animated at the same rate in the opposite order. As we can see, these animations are driven by the scroll position, but how can we implement this on SwiftUI? In my day job app, I wanted to implement something similar for this screen. When the main book button is scrolled away, I want to show a secondary floating section with a new back button, so the user can scroll and see the details of a gym session, but then still be able to book at any point. To achieve this, we can start by breaking down the problem. First, we want to know where the initial position of the element I'm interested in the UI is relative to the scroll view. For that position, we might care of the top of the view or the bottom of it. I want updates when that position changes. As the value changes, I need to calculate the values to animate. In my example, the offset of the floating area and its opacity. Since those values depend on the current value of the offset, we need to manually do that calculation, unlike setting a normal animation on SwiftUI. In this case, we have three states. 1. In the initial render of the view, the opacity of the floating area will be 0 and continue to be 0 while we scroll. 2. Before the edge of the view we are tracking aligns with the top of the scroll view, we calculate the opacity values with a linear equation. When the value is exactly 0, the opacity will be 1. 3. If we keep scrolling, the offset will increase and the opacity value will still be 1. That's the problem we are trying to solve from a logic perspective. Let's jump to the actual code that implements this. The three main pieces we'll use to solve this are 1. Geometry reader, 2. A custom preference key, 3. A name coordinate space. First, we can add a background modifier to the view we're interested in to track the offset of. The background content will be a geometry reader wrapping a color clear value. In this way, we can measure the geometry of the target view as the background maintains the same dimensions of the view. Now we can define a custom preference, where we will communicate the relative position. Preferences are a way to communicate values from child to parent views, in opposition to the environment, which is the other way around. We define a custom preference with its reduce function. Since preferences can provide values from many child views at the same time, the reduce function job is to determine how to combine those simultaneous values. In this case, we only care about the latest value. For the value we will set in the preference, we will need to use the name coordinate space to be to the same one to the set to the scroll view. Then, with the geometry proxy, we can convert the frame to that coordinate space, effectively measuring the offset of the bottom of the view to the scroll view itself. The preference is important as the geometry of the view changes, the preference value will change as well. So that's how we keep track of the updates. Finally, we use a onPreferenceChange modifier to react when that preference value changes. In this case, we just set a value to a state property. Now for the floating area, we need to calculate the opacity and offset given the target position value. These are simple segmented linear equations where I adjust the parameters to achieve the effect for the duration I want. And that's it. Now we have the animation we want, and if the target view changes position, the animation will continue to work correctly. And just to wrap this, I can make this behavior easy to reuse if you want to. In this case, I created a view modifier that attaches the geometry reader, uses the custom preference, and uses a callback when the position changes. This modifier still needs the name coordinate space as a parameter, but now it's way easier to use the custom preference, so it can stay private. I hope you liked the effect, and now you're ready to use it in your own apps. Subscribe to my channel for more iOS and macOS content like this. If you enjoyed this video, you can check how I structure the navigation of my day job app next. Until the next one.